Imagine your new AI feature has been live for a month. Your daily active users are up, load times are fast, and the dashboard looks flawless. But for a key segment, the product has completely stopped working. You're looking at a pristine interface, while the system rots from the inside out. With traditional software development, systems are deterministic. You write a specific set of rules, users input data, and the software consistently produces the exact expected output. AI models operate on a probabilistic system. They ingest massive amounts of unstructured, chaotic human data and generate a best guess. The output is a probability, not a certainty. This means standard product requirements documents and traditional acceptance criteria become fiction the moment you launch. You simply cannot capture infinite edge cases and probabilistic outputs in a static list of requirements. Right now, 85% of product managers lack the specialized skills to evaluate an AI model once it ships. They know how to build features, but they don't know how to monitor artificial intelligence in the wild. Relying on traditional analytics to manage an AI product leaves a massive gap in your data. If you can't see how the model is interpreting data, you can't see when it starts to fail. This split-screen layout illustrates the disconnect. On the left, we have the traditional product manager dashboard, tracking standard business metrics. Look at traffic. Your traditional dashboard might show daily active users hitting record highs, but high traffic alone can mask underlying degradation in the model's logic. That's where we look to the right side to measure concept drift. Concept drift happens when the real-world user data diverges from the data the AI was originally trained on. As unseen inputs hit the system, the model's accuracy splinters and drops. Next, compare speed metrics. Standard analytics track app load time. AI Observability tracks prediction latency, the time it takes for the model to actually generate a probabilistic response. A lightning-fast user interface means nothing if the underlying AI takes too long to process a prompt. If the app opens instantly but spins for 10 seconds waiting for inference time, the user experience is broken. Finally, look at user feedback. In a traditional app, users file bug reports when a button doesn't work. With AI, users rarely report slightly inaccurate or unhelpful outputs. They simply churn. You need automated outlier detection to catch those weird responses before the user leaves. Traditional metrics only measure the health of the software container. Observability metrics measure the actual intelligence and integrity of the product itself. Let's look at how this plays out in a live e-commerce recommendation engine. A sudden viral trend hits social media, and thousands of new users flood the site. This introduces massive, unpredictable purchasing patterns into the system. This chart shows exactly what data drift looks like. Tight clusters of normal user behavior are quickly overwhelmed by chaotic data. The AI scrambles to find patterns and starts recommending completely irrelevant items to your core, loyal buyers. If you rely on traditional KPIs like total sales, your metrics will lag weeks behind the event. The damage is done long before the financial line plunges. Without an observability dashboard, you are reduced to reacting to lagging financial postmortems, instead of proactively steering the health of the model. The most common organizational mistake is treating AI as an engineering-only problem, while the product manager waits to measure business outcomes. Product managers need to step into the technical layer. You have to take ownership of the exact point where model performance directly impacts user value. First, define explicit failure conditions. Map out exactly what unacceptable model degradation looks like, and set triggers to alert the team before users notice a drop in quality. Second, establish strict fallback states. When the AI's confidence score drops below 70%, the system needs to automatically switch to a deterministic, rule-based backup plan so the user isn't left stranded. Third, align stakeholder expectations. Ensure that rigid enterprise sales commitments account for the flexible, probabilistic timelines required to train and tune machine learning. Successfully building AI requires a shift from shipping static features to managing dynamic systems. It means letting go of absolute certainty to focus on steering the model's health in real time.
Thanks for watching. Subscribe and like.